Hello my dear students, welcome to my YouTube channel that's Concepts of Chemistry. Before starting today's lecture, please do subscribe my channel. My dear students, today I'm going to teach you how to evaluate the number of spectral lines per electronic transition, and this topic is also termed as induced transition. So what actually happens? When a high energy photon strikes the electron in an atom, the electron gains energy from that photon and jumps to higher energy orbits. In higher energy orbits, the electron being unstable comes back to the original orbit. Now, when the electron comes back to the original orbit, it emits certain number of photons as that electron will pass through all the energy orbits coming in its path when it is coming back to the original position. So, with each photon, there will be the formation of one line. One photon will make one spectral lines. So you have to evaluate the number of photons emitted. You will get the number of spectral lines. So now let's start about this. I'm writing when a high energy photon, when a high energy photon strikes the electron, when a high energy photon strikes the electron in an atom, in an atom. The electron gains energy from that photon and jumps to any higher energy orbit. The electron gains energy. The electron gains energy from that photon and jumps to higher energy orbits. Jumps to higher energy orbits. The orbit number on which the in which the electron is jumping will depend upon the energy of the photon which is striking the electron. Let me write this thing. The energy orbit, the energy orbit in which electron is finally entering, in which electron is finally entering, will depend upon the energy of the photon, energy of photon which is striking the electron, which is striking the electron. Now, in the higher energy orbit, the electron will feel instability. The electron will not be stable there, and that electron will come back to the original orbit. Here I am writing the electron being unstable in higher energy orbit. The electron being unstable in higher energy orbit will come back to will come back to the own original orbit number, will come back to own original orbit number by emitting certain number of photons, by emitting certain number of photons. as, very importantly, as that electron will travel through all energy orbits, will travel through all energy orbits while coming back to original orbit. While coming back to original orbit. This thing you will get cleared in the diagram while coming back to original orbit. Now, one photon emitted, one photon emitted by electron will form one spectral line. So your main motive is to evaluate the number of photons emitted. So you will get the number of spectral lines formed, because one photon emitted forms only one spectral line. So in the next line I am writing, in a paragraph I'm writing, there will be formation of spectral lines. There will be the formation of spectral lines due to the emission of photons by electron. Due to the emission of photons. Due to the emission of photons by electron. And you can also term it as emission spectral lines. You are going to evaluate emission spectral lines because it's a photon emitted by electron. Emission spectral lines. Now I am writing the number of spectral lines formed, the number of spectral lines formed will be equal to the number of photons emitted. Now this is the diagram that I have made for you. I have taken the nucleus and I have taken the 6 orbit numbers. Now it's the orbit number 1, the orbit number 2, the orbit number 3, the 4, the 5 and the 6. Now assume that electron is present in the first orbit. Let's take it as an example of hydrogen. The electron is present in the first orbit. Now what will happen? A photon of very high energy, a photon of very high energy, I'm writing photon of a very high energy whose energy is equal to the difference between the energy of 6th orbit and the first orbit. The energy of photon is hc by lambda, and this value is equal to the energy of 6th orbit minus the energy of first orbit. So what will happen? This photon with a very high energy is coming and will strike this electron. So due to which this electron acquire that much amount of energy which is equal to the difference of the sixth orbit and the first orbit, so the electron will jump directly to the sixth orbit. Now electron is present in the sixth orbit. Now electron is unstable in sixth orbit. It will try to come back to the first orbit by emitting certain number of photons, but now electron will not directly come to the first orbit. Firstly, the electron will jump to the fifth orbit, then fourth orbit, then third, then second, then finally one. Now here you have to evaluate the number of photons that have been emitted. Now when the electron jumps from 6th to the 5th orbit, it will emit one photon. Now electron is coming from 6th orbit to 1st orbit, so it's a one photon. I got the one spectral line. Now when the electron comes from 5th to the 4th orbit, it will emit two photons. You have to increase one photon at each transition. 6 to 5, it was the one photon. Now 5 to 4, the electron will emit two photons. Two photons, you will get the two more spectral lines. Now the electron will come from 4th orbit to 3rd orbit. Now you have to increase one photon again. Now from 4th to 3rd, the electron will emit three photons. Now from 4 to 3rd, the first photon, second photon, and the third photon. The three photons are emitted. You got the three more spectral lines. Now electron will come from 3rd orbit to 2nd orbit. You have to increase one photon again. Now there will be the four photon emitted when the electron comes from 3rd orbit to 2nd orbit. Now from 3rd to 2nd, the four photons. First photon, second photon, third photon, and the four photons. You got the four photons, so you got the four more spectral lines. 1, 2, 3, 4. Now the electron will jump from 2nd orbit to 1st orbit, which was the original position of the electron. Now you have to increase one photon more in this case. Now from the transition of electron from 2nd orbit to 1st orbit, it will now emit 5 photons. Now 5 photons. So second to 1. Now it's a first photon, second photon, third photon, fourth photon, and a fifth photon. You got the 5 more photons from when the electron makes a transition from 2nd orbit to 1st orbit. You got the 5 photons, so you will get the 5 more spectral lines. So 1, 2, 3, 4, and the 5. So now let's count the number of spectral lines. You got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. In total, the electron has emitted 15 photons while coming from 6th orbit to the 1st orbit, and you got the 15 spectral lines. So here we got 15 spectral lines. I'm writing 15 spectral lines will be formed as 15 photons have been emitted when electron makes a transition from sixth orbit to the first orbit. So we got 15 spectral lines. If let me alter a question. I'm giving you a question. How many spectral lines will be formed how many spectral lines will be formed when electron transits from sixth orbit to the second orbit. I have altered the question. Now finally electron is entering in the second orbit, not in the first orbit. For that thing you have to again count the number of photons. Let's come back to diagram. Let's count the number of photons when the electron comes from sixth orbit to second orbit. See the diagram carefully. The first photon, second, third, fourth, fifth, sixth, 7, 8, 9 and the 10. You got the 10 photons emitted. 10 photons emitted when electron makes a transition from sixth orbit to the second orbit. Now these are the 10 photons from sixth orbit to second orbit. So you will get the 10 spectral lines. So you have to carefully read the question. How many spectral lines have been asked for which transition number? So you got the 10 photons for 10 spectral lines when the electron makes a transition from sixth orbit to second orbit. When the electron is making transition from sixth orbit to first orbit, we got 15 photons, we got 15 lines. When the question is asking from sixth orbit to only second orbit, we got the 10 photons, so we got the 10 spectral lines. We are also having one formula. Let me write that formula. Number of spectral lines formed, the number of spectral lines formed will be equal to the n into n minus 1 divided by 2. Now very importantly, this formula is only applicable only when electron is coming back to first orbit. Please always keep in mind this formula is only applicable when the electron is coming back to first orbit. If the question is asking for second orbit or third orbit, when the electron is coming back finally to the second orbit or third orbit, you have to make a diagram like this. But when the electron is coming back to the first orbit, you can directly apply the formula. Now here the electron was finally in first orbit. Initially the electron was in the sixth orbit. The 6 minus 1, sorry. So what is n over here? What is n over here? I am writing it is the orbit number in which electron is initially present. The electron is initially present. Now the electron is initially present in the sixth orbit. Now when the electron is coming from sixth orbit to first orbit, you can apply this formula. And again I'm saying this formula is applicable only when the electron is coming back to the first orbit. Only then you will apply this formula. Now when the electron is making transition from sixth orbit to first orbit, you got your n to be 6. Now just put this value in the substitute this value in the formula. The number of spectral lines will be equal to the 6 into 6 minus 1 divided by 2. This thing comes out to be 6 into 5 divided by 2. That comes out to be 15 lines. Same way, here I have calculated the number of photon to be 15. We got the 15 spectral lines, and you can also use the formula, but this formula is only applicable when the electron is coming back to the first orbit. If the question is asking when the electron is making transition from sixth orbit to second orbit, then you have to go through this long root method, and you have to evaluate the number of photons, then you have to evaluate the number of spectral lines, which is equal to the number of photons emitted. So that's all for today. I hope you all understood today's lecture. If any student wants to book a paid one-to-one online class to clear their doubts, then she can contact me. My phone number is mentioned on thumbnail of this lecture. Please like, subscribe and share my channel to maximum number of students. Don't forget to press the subscribe button. Stay blessed.